Assalamu alaikum. This is Musab and this is my project Sarjana Muda 1 or the PSM1 presentation video. My research topic is a comparative analysis for machine learning methods on Android malware classification. This is presented by me and supervised by Dr. Johan bin Muhammad Sharif. My presentation contents are based on the 5 chapters that we have did. So the chapters: introduction, literature review, methodology, design, implementation, conclusion. Moving on, introduction, we have concept, problem background, problem statement, objectives, and scopes. So for the concept, I have included all of my work phases into time slots. So I have done within these time slots, and I have tried my best to finish up the work as per this concept because I have done it. So it starts with the supervisor selection and ends with the final draft submission to the supervisor. So just moving on. The problem background: from June 2016 to March 2020, nearly 10.5 million Android malwares were detected out of all known mobile devices malware. As of December 2020, more than 3 million apps are available on the Google Play. So, and as you know, the Google Play is the platform for Android devices. So, because of the popularity of the Android operating system, the Android malware has seen a huge growth in popularity. As a result, the users are having difficulties keeping up with the increasing threats that is shown in the Android platforms. So the problem statement is detection of new and improved malware is very difficult as there is no precedence. A constraint of machine learning approach is escalating false positive rate. So, and this is because inefficient feature selection techniques, inaccurate and repetitive features, and unsuitable algorithms for classifier generation. So, according to dynamic analysis, malware can still be active while acting inactive or dormant. So that is why it is really nearly impossible to detect malwares early on because they kind of be sleeping and then later just destroy the whole thing. So it is a widely accepted that Android's permission-based security paradigm provides inadequate protection because we just normally use that give out permissions instinctively when we use our Android devices. So that's not a good thing. So let's moving on to research objectives. We have 4 research objectives that are to study the existing malware classification technique on linear and nonlinear models, to apply machine learning methods in classifying a malware on controlled dataset, to apply supervised machine learning classifiers to extract malware based on API calls, permissions, and directory paths in Android. And those are 3 specialized topics so that we can take it from the API directory. To evaluate comparative analysis for the findings on the parameters like precision, recall, F1, and accuracy, or the F measures. So we have a research scope. This research will implement up to 3 machine learning methods. We have decided to go with 3 machine learning, and we decided to compare their scores and all. The comparison will be based on the precision, recall, F measures, and the accuracy of the malware dataset classification, our chosen datasets. This research will use advanced applied models to classify malwares using RapidMiner for the initial steps, and the Python to improve the algorithm codes so that we try to go and improve the algorithm so that it gives more accurate results than already given. So this is the second chapter, the literature review, the malware on Android apps, and then malware analysis methods, classifying methods, and the solution to solve problem solving. It's like the problems that we face during the literature review. So malware on Android. So malware is a computer software that is specially designed to target, corrupt, destroy, or impair computers, computing devices, or connections, and their networks. In comparison to other operating systems like iOS and Windows Mobile, Android has the greater malware issues because everyone nowadays uses Android. Maybe they use iOS too, but they also they also use Android just to get the kick out of it. Which is with each passing day, harmful software's behaviors evolves from spyware and rooted exploits to more destructive and invasive forms on Android platforms. So Android analysis method. Generally, we have 2 types of analysis method, that is the static analysis and the dynamic analysis. And also we have the linear and non-linear type. So in the both linear and non-linear type, we have both the static and dynamic analysis. So we are only gonna stuck with the static analysis for this research purpose. So as you can see, it is a conservative analysis, detects illegal states and transmissions, and it also represents all possible threats and transmissions in all possible cases proceedings. So it takes everything one by one, unlike the dynamic analysis, which just depicts a specific topic and then just go on with it. So classifying methods. First of all, what is a classifier? A classifier is a machine learning model that is used to discriminate different objects based on certain features. And we have included three kind of classifiers for this research. That is the decision tree. A decision tree is a supervised machine learning classifier when the data is continuously split according to a certain parameters like nodes and edges. It's like basically taking a yes or no. It's like if the criteria are set, then it says yes. If the criteria don't match, then it's no. Simple decision tree. So, and then we have the random forest. It's a supervised machine learning classifier which consists of many decision trees. It's like a decision tree but with hundreds and thousands of them, and then making the decisions for them. It is used in bragging and feature randomness to create uncorrelated connection, and this is where it comes really handy, because in this section it is really by far one of the best. So naive bias, a naive bias classifier is a probabilistic machine learning models. It's used for classification tasks. The classifier is based on the bias theorem, which is like gives that if A is related, then what is the possibility of B coming along? So, and different topic, that is the we have three kind of classifiers. That is the supervised one, the non-supervised one, and then there is the semi-supervised one. So in this research, we are gonna only focus on the supervised one. Suggestions to problem solving. We utilize permissions and API calls together as major attributes, and machine learning algorithms to automatically retrieve features, and identification begins benigns from malicious and rest from using the APK files, because APK file contains the permission API calls, and which we can classify as a feature and then analyze them to differentiate. It's like what features we can categorize them into. So this can be done in three steps. That is the data decompress and extraction, feature extraction and selection, where we can feature selection is happened, then extend the malware classifier using our Python codes and all. Next is the methodology, the workflow, research structure, dataset performance measure, programming methods and tools. So workflow, research, we have three phases for the workflow. First phase workflow, in this step, the dataset obtained from a feature which contains APK files from various Android application will be subjected to the four sub-processes mentioned above. And the second phase, this section will focus on algorithm performance in terms of combined instances, set derived from permission and API calls, defragmentation, because with using the four subphases, we will just defragmentation everything and then clear them out as an instance of everything to figure out our feature selections. So the last phase, in this phase, the performance of all the three machine learning technique in classifying obtaining parameters will be evaluated, and the best techniques will be chosen for further analysis. Research structure, as we have mentioned, that the four substructure, these are the four substructure to extract the raw data from the database and select them as a feature generator. It's like how we separate them and which feature we can just call them up. So then there will be four subphases that must be completed before the main phases of the research obtained. Then there are three main steps for the studying will be based on the research goal, and each stage will produce outcome. That means all of these above phases will represent the overall design for the research. When it comes to data set, we have chosen the dataset, Android malware dataset for machine learning 2. It is also known as the Revin 215. This dataset contains a feature vector of 215 attributes. It has a total of more than 15,000 applications, and above them 5,500 are benign malware apps, and the rest are the benign apps. Performance measure, as it is really pretty simple, and it's used everywhere, in every machine learning classifier algorithms. And those are the recall, precision, and F1, and I have also included the accuracy for better judgment and all. So programming methods and tools, we are going to use two tools. That is the RapidMiner, and the programming language will be Python, because the RapidMiner for the initial stuff, so that we can just have a feel is how it works and how the classifier performs, and then we will just using the Python, we will add on more codes so that we can improve the classifier algorithms and all. So design and implementation, it has proposed solution, experiment design, parameters, and then testing. So proposed solution is after feature retrieval and selection using the steps in methodology, we create instances for the malware classifiers. The first one, following instance retrieval, we will evaluate malware that has the same class levels as the extracted features. Then remove malware but that has a similar vector, category, characteristics and save singular features as reference to work with the classifier. That is really important. In this technique is if this technique is followed, malware samples across all malware families will be reduced, and the process will provide extremely extensive coverage of existing Android malware and features from online sources, because it can then after we train with this algorithm, it can then automatically select those features. Experiment design. The study will evaluate the algorithm's performing using a variety of classifiers, including random forest, decision tree, and naive Bayes, our three included ones. The primary objective of research is to instigate permission and API calls and test them in training in order to gain further knowledges. Additionally, through feature selection, we will choose the most appropriate classification methods for malware classification. The testing set for each class's classification method will be generated independently with replacement from the data base testing data. Parameters and testing. As we have initially done the parameter and testing, these are the results that we get. So according to previous research, the classifier that outperforms in the experiment on both sample set is decision tree, which achieves classification accuracy of 97.7% on the testing sample and 100% on the training sample. That is a lot. But and on the same side, the random forest performs average, and on the both sets, the naive Bayes performs the lowest because it's by far the simple one. And then there comes conclusion. So the conclusion has outcome expectations from this research, the limitation that we faced, and the future work that we're going to follow for PSM2. So the outcome expectations are the three research outcomes. The three research outcomes according to the objectives are as follows. The first outcome is investigating common malware behaviors and setting up a feature-based learning framework for Android malware classification to create a profile of malware behaviors and a malware feature extractor from the Android APK file dataset. The second outcome is using the random forest, the decision tree, and the naive Bayes technique to extract malware apps and their behavior characteristics and from the dataset. The final outcome is the comparative study of the three distinct techniques and develop a system for visualizing all experimental data. The best performing models result will be gathered and discussed further. Limitation that we faced, and those are the primary constraints are any machine learning algorithm requires massive stores of training data to implement a data mining framework in real world operation and a lot of time. The proposed experiment is based on static analysis and does not include dynamic inspection, so we're going to have to pinpoint on every aspect. The systems classified models qualify is highly dependent on the presence of represent malicious and benign applications. And lastly, the machine learning involves space complexity, and sorting out the feature is a tedious work. For feature work, the study needs to implement the Python programming language to come up with an improved classifier using the above methodology, and also look into the Android directory bus to include in the classifier to extract more unique features to classify the malware and present better results on the parameters like precision, recall, F1, and accuracy. So these are our future work that will be done, and most of the work that we didn't do will be done on the PSM1. And thank you all for listening, and Assalamu alaikum.